Hey everyone, good morning. Good morning, all of you. Welcome back again to our bridge course for the preparation of NEET 2026. As you all know that the agenda of this bridge course is to strengthen your fundamentals. But apart from that, we always keep talking about the predictable problems that may come in the NEET 2026 exam. And I'm hoping that all the students who have gone through, the entire bridge course till now, definitely you will be getting multiple problems which will be either directly from the models which we have discussed, or they will be inspired from those models. Means completing the bridge course very nicely will definitely make you capable to attempt some critical models which will be expected in the NEET exam. All right. So here, today's target topic is again the pseudo force. Yesterday we started our discussion with pseudo force and some critical topics like relative velocity, conservation of momentum, and same in pseudo force, where students feel a lot of difficulty. I preferred to take them in two different phases. In phase one, in every of these topics, we have understood the concept, we have understood the patterns and some other models. But in phase two, we put a nice full stop for all the topics. All right. So similarly, in our last discussion yesterday, we started with the topic of pseudo force from laws of motion. And here today, we are going to successfully complete that. So the thing is that if we talk about the topic pseudo force is a force which is not real, as the name itself suggests. It is a fictitious force or pseudo, not existing in reality, but comes into the picture while applying Newton's second law, provided the observer itself is accelerated. So whatever key points we have discussed, let me give you a quick recap for that. Then one by one, we will go ahead with the relevant models. So what we have learned so far is that pseudo force will be applied on the object irrespective of the state of motion of the object, but only when the observer is accelerated. So whether the pseudo force is to be applied or not to be applied, that is not a decision which is to be made from the side of the object. That is a decision which is to be made from the side of the observer. So if you as an observer are accelerated, which means you are a non-inertial frame of reference. Whenever we deal with non-inertial frame of reference or accelerated observer or accelerated frame of reference, we apply a pseudo force on the object. The direction of pseudo force will be opposite to the direction of acceleration of the observer, which means if I am the observer accelerating forward, mind it, I am not talking about direction of my motion. I am talking about direction of my acceleration. So I may be moving in any direction, right? Velocity can be in any direction. We don't care. We care about that where is the direction of the acceleration. So if my direction of acceleration being an observer is in the forward direction, then on any object I am observing, I will apply a pseudo force in the reverse direction, backward direction. The direction of pseudo force is clear. Now what about the magnitude, sir? F is equal to ma. So the mass will be the mass of the object on which you are applying or considering pseudo force. But acceleration will be acceleration of the observer, my acceleration, but in opposite direction. All right. Once again, point number one, when to apply pseudo force, sir? Pseudo force must be applied when you as an observer or frame of reference are yourself accelerated. We don't care about the state of motion of the object. We care about the state of motion of the observer. So if observer is accelerated, you are going to call it non-inertial frame of reference. All right. On which pseudo force is applied? Observer or object? Pseudo force is applied on the object. What is the direction of pseudo force? Mind it, it's not a real force. It is an observed or felt force. So the direction of pseudo force will be opposite to the direction of the observer. Magnitude wise, whenever you write m into a, the mass will be the mass of the object and a will be the acceleration of the observer. M will be the mass of the object and a will be the acceleration of the observer. All right. Pseudo force must be applied on the object Whenever observer is accelerated, mass will be mass of the object, acceleration will be acceleration of the observer, but in opposite direction. That's the end of story. Now, let us take a quick recap of the concept we have learned so far. So, yesterday I considered a situation while introducing the topic. The situation is that there is a 5 kg block kept or placed on a horizontal surface, which is, the block is at rest right now. If the block is at rest, maintains the state of rest, which means actually, in reality, it is in static equilibrium. The net force acting on it is 0. All right. So now I have considered 3 observers. Observer 1, who is also at rest. Observer 2, who might be moving with uniform velocity in any direction. Observer 2, constant velocity, but it can move in any direction. We don't care. Observer 3, it's an accelerated. It is moving with constant acceleration. So it is an accelerated observer. So if the observer is at rest or the observer is moving with uniform velocity, whether the observer is at rest or observer is moving with uniform velocity, you call these observers or frame of references as inertial frame of references. So inertial frame of reference is the frame of reference in which you will say acceleration of frame of reference is 0. Acceleration of frame of reference is 0. That's the thing. All right. Whereas if I talk about non-inertial frame of reference, acceleration of frame of reference or observer is non-zero. Acceleration of frame of reference or observer is non-zero here. All right. So whenever you talk about, like I have talked about their observation, and I have realized that whenever the observer is at rest, then there is no pseudo force. Directly Newton's second law can be applied. Whenever the observer is moving with a uniform velocity in any direction, then also there is no requirement of pseudo force and Newton's second law can be directly applied. But whenever we talk about an accelerated observer, technically called a non-inertial frame of reference, in that case, as per our observation, we must be applying a pseudo force. We have got one fictitious force, or you can say that's not a real force, that is pseudo force over there. We realize that the observer, when the observer is accelerated right, the pseudo force came out to be left, means opposite. The mass will be the mass of the block, means mass will be the mass of the object, and acceleration will be the acceleration of the observer, as I already said, in the opposite direction. I hope that's clear to you. Hi Radha, Shobha, Rahul. Good morning. Good morning. I'm good. I hope you people are also doing good. Right. Today is Eid. Yes. Eid Mubarak to all of you. Right. Have a happy day ahead. We must celebrate all the festivals. Festivals are an opportunity to, stay happy, to make others happy. Right. Good. So, yeah. So our topic is again going on, the pseudo force part. So this is the concept in front of you, which suggests you that why there was actually a need of this pseudo force. Okay. For our discussion ahead, we will be taking this pseudo force as a tool or a technique. All right. So as I always say, if we are dealing with a tool, all the questions that can be done with using the technique can also be done without using the technique. So going forward, for first few models, I have already discussed that the analysis or conclusion which can be done with pseudo can also be done without pseudo. But slowly moving forward, my preference will be to deal with the same models, to do the case studies involving pseudo. Because obviously, when we will learn pseudo force, when we will practice a lot of case studies based on pseudo force, then only we will be able to appreciate the beauty of this technique. All right. But always remember, anything that can be done with pseudo can also be, any problem that can be done with pseudo can also be done without pseudo. Okay. Next. Inertial and non-inertial frame of references. These are two types of frame of references. Inertial frame of references are those which are not accelerated, which means either the observer is at rest or maybe moving in any direction with uniform velocity. It's not necessary it has to be at rest. It may be moving with uniform velocity as well. So we are not basically interested in focusing on whether it is at rest or in motion. Nope. We are basically focusing on whether it is accelerated or non-accelerated. So if it is not accelerated, it's inertial. Newton's second law can be directly applied. If it is accelerated frame of reference, in that case, the Newton's second law's modified version can be applied, which means you will say net external force plus pseudo force. Net external force plus pseudo force will be m into a, mass of object, acceleration of object, okay, m into a. But here when you write pseudo, then pseudo force will be mass of object into minus of acceleration of the observer. I think that's clear. All right. By definition, that's a JEE Advanced previous year question. By definition, Earth is considered to be a non-inertial frame of reference because it keeps on revolving around the sun in elliptical orbits, which means it is definitely accelerated. So Earth considered to be an accelerated frame of reference or non-inertial frame of reference. But if you stand on ground or Earth and observe an object which is on Earth, then there is no relative acceleration between them. If there is no relative acceleration, so mathematically there is no need to apply pseudo force. So pseudo force is generally applied when the acceleration of frame of reference is non-zero, which means the observer is accelerated. By definition, Earth itself is considered to be accelerated and hence non-inertial. But if you as an observer are on Earth, you are observing the object on the Earth, there is no relative acceleration, hence there is no need of pseudo. Everything is written. And this is what we have already covered, so I am taking you with a good speed, okay? We are taking a quick recap. Models, when they will come, new models, definitely I'll be slowed down. So here, there is a concept of apparent weight, that is the first case study which I have taken in order to show you that how these case studies can be done with pseudo, can also be done without pseudo. So apparent term means observed, apparent means observed, okay? So your actual weight is always mg. But whenever you are standing over a weighing machine, the normal reaction offered by the weighing machine on your feet, that will be, that reading will be your observed weight. Because you stand over the weighing machine and then you check the reading. That is the weight that you observe, although your actual weight is always mg. So here, observed reading of normal reaction basically is something in which we are interested in. So in case 1, when there is a lift or elevator, inside which there is a block and elevator is at rest, or maybe moving in any direction with uniform velocity. Velocity can be constant in any direction. We don't care about it. In that case, we have considered two observers. One is inside the lift, one is on the ground. But in this case, both the observers are inertial only. The reason is lift was not accelerated. So this is also inertial frame of reference. And here also it is inertial frame of reference only. This is also inertial and this is also inertial. Both are inertial frame of references. Both are inertial frame of references. Okay, there is no difference between them, and hence it will not, you will not be that much interested, you will not be able to that much distinguish on the basis of this case study that how these two observers are different. But if I consider case 2 in which the lift is accelerated up and in case 3 in which the lift is accelerated down, then every time due to inertial and due to non-inertial, every time due to non-inertial, due to inertial frame of reference, their observations are different. Their observations are different. Their dealing with Newton's second law is different, but the conclusions are going to be same. Conclusion is, if the lift is accelerated up, where it is moving, sir, we don't care about the motion direction. If the lift is accelerated up, pseudo will be down. Pseudo force will be down, supporting the gravity. If pseudo will be, see, we are not interested in looking for the accelerations, whether they are supportive or opposing. We are interested in looking for the forces, whether they are supporting or opposing. So if the lift is accelerated up, the pseudo force will be down, mg is already down, they will add up and hence normal reaction will be more. Which means whenever the lift is, accelerated up, you start feeling heavier. Your legs start feeling heavier because the normal reaction increases. It balances a greater weight. Normal reaction upwards balances a greater weight. Whereas if the lift is accelerated down, pseudo force is accelerating, pseudo force is acting up. So weight and pseudo force will be in opposite direction. As a result, your apparent weight or observed weight will decrease. Apparent weight is less than actual weight. Here apparent weight is more than actual weight. Here apparent weight is exactly equal to the actual weight. And I want you to spend some time after the class with these notes. So every time there are two observers, only in case 1, coincidentally, both the observers were inertial because lift was not accelerated. But in case 2 and case 3, when lift or elevator is accelerated, then the observer standing inside the lift or elevator is to be considered as a non-inertial one, whereas the observers standing on the ground, they are to be considered as the inertial frame of references. All right, no pseudo force for the observers who are standing on the ground. Clear? Now, next is pseudo force in connected motion. I introduced the Atwood machine. In this case of Atwood machine, two masses, one pulley. The common acceleration will be bigger mass minus smaller mass into g by total mass of the system, m2 minus m1 into g by m1 plus m2. Tension will be 2 m1 m2 g by m1 plus m2. Very common NCERT model, gets repeated many times. Clamp reaction will be 2T, as pulley is considered to be massless, so there cannot be a non-zero net force on the pulley. It has to be always balanced. Upward must be equal to downward. As a result, you will say double of this. Double of this means 2T means here it will be 4m1 m2 g by m1 plus m2. This is a normal Atwood machine, the entire case. Now we introduce the pseudo force in it. Suppose this Atwood machine is kept inside the elevator and the elevator is accelerated up. If the elevator is accelerated up, don't see that acceleration is opposing the gravity. Nope. I told you, you don't have to check the support or opposition of the accelerations. You have to check them, check the support or opposition for the forces. So if the acceleration is up, the pseudo force will be acting down. So where you used to get mg, now you will get mg plus ma. As a result, every g must be replaced by g plus a. So common acceleration is bigger mass minus smaller mass. See here in this case, I assume the bigger mass is m2. Here I am mentioning the bigger mass is m1. So it is bigger mass minus smaller mass into g plus a by total mass of the system, and tension is 2 m1 m2. Instead of g, again it is g plus a by total mass of the system. Same with the clamp reaction. All right. In the second case, what did I do? I took this clamp as a spring, so that the clamp force will be given by spring reaction now, or you can say spring force. And here I have accelerated the entire setup down. But this acceleration is less than gravity, which means pseudo force will be opposing the gravity but less opposition. So gravity will be still dependent. As a result, spring will be still extended by a net force of mg minus ma. So every g will be replaced by g minus a. You can have a look. That's what we did yesterday. Hello? Yeah, I think that's clear. Now, pseudo force on inclined plane. This was the last case study which we have taken yesterday. There was an inclined plane. There was a wedge of angle of inclination theta, over which there is a block of mass m0 which is kept. All the surfaces are considered to be smooth. You know, if I release the system in conservation of momentum, also I took the same model. Very common and interesting for NEET. If you release the system, this block m0 will keep on moving downward and forward as a reaction of the contact force. Because of that, the wedge will keep on moving back. The wedge keeps on moving back. The block keeps on moving forward and downward. This is the situation. The question is that if you just disappear the wedge like magic, then definitely the block is going to be in free fall. So instead of making it disappear magically, what you can do is you can remove it. You can remove the wedge with a certain minimum acceleration such that the block will exhibit free fall. That was the question. Determine the minimum acceleration of the wedge with which it will be removed so that the block kept over it will exhibit free fall. Free fall means the block must be falling under the influence of gravity alone. So right now, the block was acted by two forces, gravity and contact force, out of which your interest is the gravity, that gravity should be, the block should be only influenced by gravity. There should not be any contact force. Once again, the block is to exhibit free fall, means gravity alone. But right now, the block is acted by two forces, the gravity as well as the contact force between the wedge and the block. So here, if you are interested only in gravity, so your indirect demand is to make the contact force zero. Now, contact force are of two types, normal reaction and friction. Since the surfaces are smooth, anyways there is no friction. So again, your indirect demand is that you want to make the normal reaction as zero. Understood? You want to make the normal reaction as zero. Now, again, if you got the indirect condition, the same condition can be implemented in the given apparatus or given arrangement by two ways. One with pseudo, one without pseudo. But now our interest is today, after today's interaction, we want to appreciate the beauty of this technique. So now we will be focusing not by two solutions of the same problem, but preferably if there is a chance, we would like to solve this problem by application of pseudo. So what did we do? Since the inclined plane is supposed to be accelerated, I became an observer and stand on the inclined plane and started observing the block. If I started observing the block, there will be a pseudo force acting opposite to the direction of my acceleration. So me as an observer, me as a teeny tiny observer here, I am accelerating like this. So the pseudo force acting on the block will be opposite. Mass of the object, acceleration of me or the wedge, but in opposite direction. So that's what had happened. Now, if I go and stand over the inclined plane, then according to me, this block can't move perpendicular to the incline. According to me as an observer on the incline, this block has only got the liberty to slide along the incline. So if it only has got the liberty to slide over the inclined, then perpendicular to the inclined, I'll balance the forces. The moment I balance the forces perpendicular to the inclined, our desired condition was A is equal to G cot phi. A is equal to G cot phi was what? Something we were searching for. Take a minute, see that carefully. Now I'm taking you towards other case studies. Other case studies, just have a look. Take a minute, observe that carefully. It's very important for NEET. All right, done. Chalo. Pseudo force on inclined plane, another model. Now, what is this another model? Again, I will take an inclined plane. Angle of inclination phi. Angle of inclination phi. Mass m. All the surfaces are considered to be smooth. All the surfaces are considered to be smooth here. This is also smooth. This is also smooth. And on the top of it, over the inclined plane like this, there is say m0 mass, which is released from rest. Last time, what did you do? You removed the wedge like this. This time, what I am doing, examiner is asking me that determine the acceleration of the wedge. Determine the acceleration of the wedge such that the block doesn't slip. Such that the block doesn't slip over the wedge. Okay, such that the block doesn't slip over the wedge. That is the situation. Last time we removed it. This time we want to entertain it. Understood? So what I'm going to do, I'm going to solve it like this. See, I will say that let us consider this inclined plane again. And let me put a block over here, and I'm maintaining some gap in order to understand it better. Now what I'll do, this wedge is to be accelerated here. If this wedge is to be accelerated here, and let me become an observer who stands over the wedge. Okay, I'll become an observer who will stand over the wedge, and according to me, you don't want it to slip. You don't want it to slip, doesn't slip. Okay, so I will apply a pseudo force on the block like this. This is F pseudo. Here I have applied a pseudo force. This pseudo force will be given by mass of object, that is m0, into acceleration of the observer. Since observer is standing over the wedge, so the acceleration of the observer and the acceleration of the wedge, acceleration of the observer and acceleration of wedge are going to be same. That is in the forward direction. So pseudo must be applied in the backward direction. All right. This angle is phi over here. Phi. Let me resolve this in that case. So I will say this angle will be phi again. So this will be pseudo, F pseudo cos phi, and this will be F pseudo sin phi. This will be F pseudo cos phi and this will be F pseudo sin phi. Not only that, I will say there will be definitely this W equals to M naught G. W equals to M naught G. Now let me resolve this. This component will be W cos phi. Okay. Just a moment. Yeah, that is the situation. So I will say this component here will be W cos phi and this component will be here W sin phi. Okay, W cos phi and W sin phi, and there will be a normal reaction like this. There will be a normal reaction N or R. So definitely what you can say, according to this observer, anyways the block had a liberty to slip along the incline, not in the perpendicular direction. But according to the question, you even don't want the block to slip down over the incline. According to the question, you don't even want the block to slip, which means perpendicular, it was anyways unable to move. Perpendicular to the inclined, it will anyways want to move, which means this must be balanced by this. But along the inclined, it had a liberty to move, but in the given situation, you don't even want it to move along the incline, which means this force must be balancing this one. This force must be balancing this one. So I will say here, for no slipping over the inclined, for no slipping over the inclined, over the wedge, for no slipping over the wedge, your Fp cos phi must be equal to your W sin phi, which means you will say M naught AW cos phi will be equal to M naught G sin phi. As a result, from here, you got the acceleration of the wedge exact value as G sin phi by cos phi is tan phi. Mind it here, last time our conclusion was something different. Last time we wanted it to exhibit free fall. If we wanted it to exhibit free fall, the desired result is G cot phi. And here, if we want it not to slip, if you want the block to stick over the wedge, this means we want block to stick over the wedge, to stick over the inclined. Okay, we don't want it to slip. We want both of them to be having common acceleration. These can be different languages. That is, acceleration of the wedge must be equal to the acceleration of the block. Acceleration of the wedge must be equal to the acceleration of the block in the horizontal direction. It will be okay. And how this thing is useful for us? How this thing is useful for us? Because we will say that suppose in the same question, I'm taking here an example that examiner is telling you that if there is an inclined plane, angle of inclination phi, if you notice, angle of inclination phi, mass m, this is m naught, and they are asking you, tell me the f naught value such that block doesn't slip, such that the block doesn't slip. This is the question. All right. So here what I can write, see, you are pushing the wedge, but if you don't want the block to slip over the wedge, which means both will be pushed for the same acceleration. I repeat, you are pushing the wedge is pushing the block, but the condition is such that if you don't want the block to slip over the wedge, which means both of them will be having the same common acceleration, so you will say here F naught required will be equal to net mass into net acceleration. So net mass is capital M plus M naught into net acceleration is G tan phi. That's what you have concluded over here. Last slide, for free fall, that was g cot phi. Here for no slipping, moving with the common acceleration horizontally, that is g tan phi, and the value of that common acceleration is g tan phi. Which mass is exhibiting that acceleration? Both of them, because both of them are sticking together. So the force required will be to provide both the masses the same g tan theta acceleration. That's why you could directly write it. I hope that is clear for us. Okay. Now, let me take you towards another one. If you want, you can take the screenshot, but by the end of the day, definitely the entire PDF will be attached to the description. Okay. The notes will be attached in the description. Let me take you further now. Again, the case of pseudo force on inclined plane, again a problem, small problem. The problem is that this time here it is mass m, here it is mass m, here it is mass m naught, this angle is phi, this angle is phi, this is a smooth horizontal table. I can also introduce friction in that, but that's gonna be discussed later on, once we have a strong command on friction. That's the pulley. Now here is an ideal string passing over the pulley connected to the wedge at this point of contact, and there is a hanging mass m dash. All surfaces are smooth. All surfaces are smooth. That is given to you. No friction anywhere. No friction on the wedge, the surface, that one. And then all surfaces are smooth, and then they are saying system is released from rest. System is released from rest. Examiner is asking you determine the minimum value, or determine the value of m naught, not minimum, in fact exact value. Determine the exact value of m dash. Determine the exact value of m dash, that is the hanging block. Okay, such that m naught doesn't slip over capital M, such that m naught doesn't slip over capital M. You want to get the value of m dash, hanging one, such that this doesn't slip over this. All right. So there is a, first of all, what we need to understand is, if you don't want the block to slip over the wedge, then they must be moving with the common acceleration, and the common acceleration for sure it is going to be g tan phi. So here people do a common mistake. Why they do a common mistake? Because just before I have told you something, that the desired force will be equal to capital M plus m naught into g tan phi. So this common mistake is basically inspired from last discussion, last problem or slide. Last slide or last problem, I have told you that the force will be equal to m plus m naught into the common acceleration, that is g tan phi. So people generally have this tendency to do it this way. This is the common mistake. They write it as the hanging weight m dash w dash, that must be equal to f naught required, which means they will say m dash g will be equal to capital M plus m naught into g tan phi. From here g and g will be cancelled. And this implies m dash will be equal to capital M plus m naught into tan phi. Capital M plus m naught into tan phi. As I said, doing this is wrong. But we need to understand, okay sir, you are telling us that the people do this common mistake, but what is the issue with this? Why it is wrong? So see, you need to understand that here, this must be pulled with this acceleration, that's true. But who is responsible to pull that? Is its weight directly responsible to pull this ahead? Nope. Its weight will be acting on it. It can't be acting on it. Because of its weight, there will be a tension created. In the string, and that tension is responsible to pull it ahead. Okay, the weight of hanging block cannot be exerted on that system. The weight, whose weight it is? hanging block's weight it is. So if it is the weight of the hanging block, it will be experienced by the hanging block. Due to the weight of the hanging block, there will be a stress or tension created in the rope. This tension is responsible to pull the system with the common acceleration. So why it is wrong? Why it is wrong? The reason is, I will say, tension T is responsible. Tension T is responsible to provide the common acceleration. Tension T is responsible to provide the common acceleration equal to g tan phi to the block plus wedge system, to the block plus wedge, and not the weight of hanging block. So here you have assumed that the weight of hanging block will do the same job of what this F0 has done on the last slide. See, F0 was directly applied on these. Here, tension is directly applied on this as a system. Okay, why you can take as a system? Because they are sticking together and moving with a common acceleration. So the directly applied force on block plus wedge is not the weight of the hanging block, it is the tension created in the rope. All right, so that's the entire situation here. And now, and now if I have to tell you the correct way of doing it, correct way of doing this, then I will say, for this correct way, we will be writing something for the hanging block, something for M dash, and then we will be writing something for M plus M naught. Okay, block plus wedge, right? So for M dash, what I can write, I can mention some forces here. I will say this is M dash G, this is tension T, and definitely its acceleration is a common acceleration down, that has to be G tan phi. Because string is inextensible, so whatever will be its common acceleration down, the same will be their common acceleration ahead. So here it is T and providing this common acceleration to the entire system, here. So what I can say is that for the M dash block, you can write it as M dash G, bigger minus smaller in the direction of bigger one. M dash G minus T will be equal to M dash into G tan phi. Okay. And from here, you can write T is equal to capital M plus M naught into G tan phi. Capital M plus M naught into G tan phi. Here they are not asking you anything regarding the tension. So if they are not asking you tension, better to add them up and eliminate the tension. So if you add them up, so minus T and plus T will be cancelled. So what I will get is M dash G will be equal to M dash G tan phi. In fact, what I can take here is G tan phi I can take common from all of them. G tan phi I can take common from all of them. And what we will get is M dash plus capital M plus M naught. Like that I will get. So G and G can again be cancelled here. G and G can be cancelled. And this will be M dash, and that will be equal to M dash tan phi, and that will be equal to plus capital M plus M naught into tan phi. Just a normal solution. Even if I am doing a bit of mistake, suppose you just focus, just verify the solution. So M dash, you take this term on this side, you will have a coefficient as 1 minus tan phi. So the final answer here will be M dash will be M plus M naught tan phi by 1 minus tan phi. I don't remember the answers. I don't have the options. So please check the calculation. Hopefully I am writing correctly only. All right. That is the entire situation. I told you, remember the common mistake, what not to do. So in physics, especially for our preparation for this national level exam, you must know what to do, but in majority of cases, you must also know what not to do. Okay, what is the common mistake? Because sometimes, even if the time doesn't permit in the final exam, you may opt for elimination approach. You may understand the psychology of the examiner that a given option is deliberately given to provoke the students to do a particular error. Okay, if you understand the psychology of like on what basis, concept building is something, problem solving is a different art, gaining knowledge is also something, but similarly, understanding the psychology of the examiner is also very important for us, about which we will keep talking the entire year. All right. So I hope the situation is clear to you and what you have to solve. If in the same problem they would have asked us the tension, then we would have considered to find out the tension by keeping the value of m dash in any one of them. Is it clear? If you want, you can take the screenshot of this. So now again, we took 3 examples for the case study of pseudo force on inclined plane. Okay, our first discussion yesterday was on last discussion yesterday was for the block to exhibit free fall. Then today we have started with the discussion of for the block not to slip over the incline, then the common force required, and then another hanging force or hanging block whose mass is required. All right, but since we have discussed a lot, let me conclude it for you now. Pseudo force on the inclined plane, we will talk about the conclusion. Okay. We will talk about conclusion now. Whatever I have taught you, I would like to conclude it for this case study. Now suppose we have the wedge. Okay. We have the wedge here, and then we have the block here, m0, this is capital M, then we have M, this is m0. All right. So situation is that here, if you are interested in finding, removing it with this, acceleration of wedge is in this direction. Acceleration of wedge is in this direction. So if you are removing or disappearing the wedge, then there is a chance that this m0 will start falling under the influence of gravity alone. So I will say for free fall, we will have this acceleration of wedge is equal to g cot phi. In that case, the normal reaction N or R or contact force, the normal reaction N or R or contact force, that's gonna be equal to 0. And the force required to do the same thing is, you will say, sir, you want to just remove the wedge. If you just want to remove the wedge here and the block will be falling under the influence of gravity, so the mass will be mass of wedge and into acceleration of wedge. So it will be equal to m into g cot phi. M into g cot phi. That is the situation. Here, if you talk about the same, but in this next illustration which we talked about is that if you have here, you provide the acceleration to the wedge like this. Now do understand, if acceleration of wedge is more than the block will rising up. If the acceleration of the block will be less than the acceleration of the wedge is less than the block will be sliding down. But if you don't want the block to slip neither upward nor downward, which means you don't want any of them to be the winner and any one of them to be the loser, which means in that case, for sticking together, for moving together, that is no slipping condition, you get this acceleration of wedge as a g tan phi. That's what we have discussed, right? That is g tan phi. Normal reaction N or R or contact force, because contact force, other component, friction is not considered anywhere. Normal reaction or contact force, that is equal to mg by cos phi or mg secant phi. Mg by cos phi or mg secant phi. How you are getting it, sir? I will write that. I'll write that. I remember the result. I want you to remember the conclusion. But how do we get that? I'll explain it to you. And if they are asking the F required, force required to attain this condition, horizontal force required to attain this condition, here in this case, you just wanted to remove the wedge. Here you want both of them to be moving together. So the mass will be combined mass m plus m0 into the common acceleration g tan phi. Mass will be combined mass into the common acceleration g tan phi. And now let me explain it to you that how do we get that? How do we get that? So can I say, if you stand over here as an observer, since the acceleration of the wedge is in the forward direction, the pseudo force will be in the backward direction, As a result, there will be two components. If the angle of inclination is given phi over here, so you will say this angle will also be phi. So there is a pseudo force Fp cos phi component, and there will be a pseudo force component Fp sin phi. Similarly, if I denote the weight W equals to mg, so this I know that this is W sin phi, and this I know this is W cos phi. Apart from that, if I denote this, normal reaction N or R, so definitely for no slipping, you have balanced this W sin phi with Fp cos phi, but you should also balance the forces perpendicular to the inclined Fp sin phi plus W cos phi. So here what I can write is, I will say N or R will be equal to Fp pseudo's sin phi component plus W cos phi component. All right. Pseudo sin phi component is m naught acceleration, m naught into acceleration of wedge, okay, sin phi plus m naught into g cos phi. Right, mass of block into acceleration of the wedge, acceleration of the observer. Let's keep its value here. M naught, if I take common, AW can be written as G tan phi into sin phi. AW can be written as G tan phi into sin phi plus G cos phi, because M naught has been taken common. Now similarly, if I take G also common, M naught G, so I will get tan phi here. Tan phi is basically sin phi by cos phi. Sin phi by cos phi, another sin phi is already there, plus G has been taken common, that's cos phi. Let's imagine that we are taking the LCM, space is less, so let us imagine that we are taking the LCM, that's sin square phi plus cos square phi. Sin square phi plus cos square phi is nothing but 1 in the numerator, so that can be written as m naught G, and the denominator it will be cos phi. Numerator sin square phi plus cos square phi will be 1. Okay, so mg by cos phi, m naught G by cos phi here. M naught G by cos phi, or M naught G secant phi, you can say. I hope that's clear. All right, so this way I want you to remember both the conclusions. This slide is very important. Make sure you take a screenshot of that. Vamsi, thank you. I'm glad that you are understanding everything very well. And I would suggest all of you, even if you have started, listening to these lectures in the middle of the bridge course, then also in the last 2 weeks, whatever I have taught, that is going to be very, very beneficial for your journey ahead with physics. Okay, make sure you go through every lecture in the bridge course, whatever is already taught. Chaliye, I hope you have taken the screenshot. Let me, take you towards another one. Pseudo force on liquid particles. Pseudo force on liquid particles. There is a common property here. I will not talk about the fluids or liquids too much right now. In the chapter of fluids or liquid, we will talk separately. But a small property I'll mention here, that free surface of liquid is always normal. Or perpendicular. Free surface of liquid is always normal or perpendicular to the net force. Okay, this is a very important property of liquid. Why is that, sir? Why this happens? Liquids possess tangential stress, don't possess strain, don't possess whatever it is. No technical language, no technical aspect of liquid or fluid today. Some other day we will talk about, but this property is always valid. Now, how we will see the connection of pseudo force with this property, that I'll show you. So illustration 1 is, there is a beaker. Okay, beaker is at rest or moving with uniform velocity. Beaker is at rest or moving with a uniform velocity or a constant velocity. All right. Now, what is happening? If you consider a liquid particle, P, surface liquid particle, P is surface liquid particle. Then this surface liquid particle is only experiencing one force. W equals to mg. This surface liquid particle is only experiencing one force, and this one force can be called as a net force. If you have got the net force here, then perpendicular to it, you should imagine the free surface of the liquid. That's what I have written. The free surface of the liquid is always normal or perpendicular to the net force. Okay, it's a very common situation, which means if you take a beaker and either you keep it at rest or you move it with uniform velocity, not suddenly if you are moving, it will spill over because it is an accelerated motion. I'll show you that also. But I think here that's clear for us. I'll just, I'll draw all the cases for your comparison, for your better understanding. Okay, so this is the first situation in front of us. Let me take another one. Illustration 2. In this illustration, I am saying that the container is accelerated in the forward direction. Acceleration of container is like this. Container is accelerated in the forward direction. This is given to you. All right. So if it is given to you, and now if you consider a surface liquid particle P here, surface. So one is W, which is equal to mg. One is pseudo. If the container is accelerated in the forward direction, the pseudo force acting on it is in the backward direction. That is m into AC, mass of the liquid particle into acceleration of the container. Mass of the liquid particle into acceleration of the container. By parallelogram law, its resultant is somewhere here. By parallelogram law, the net force is somewhere here. If net force is somewhere here, the free surface of liquid is supposed to be perpendicular to the net force. The free surface of a liquid is supposed to be perpendicular to the net force, so it will attain this shape. So if you accelerate it less, it will tilt a bit. But if you accelerate it more, definitely it will start spilling out like this. It will start spilling out here. Why it is happening? Why do you observe this spillover? You observe that in the daily life, right? You observe that because of the same property of the liquid, that its free surface is always perpendicular to the net force. Here, the container was not accelerated. Again, I'm repeating, in pseudo force, we are not interested in the direction of motion. We are interested in whether there is an acceleration of the frame of reference or observer or not. And if there is an acceleration, then in which direction? Okay, so we are interested in acceleration, not the velocity. So here, we introduce the pseudo force. Let's talk about the case of washing machine. Illustration 3. Let us talk about the case of washing machine. Now in the case of washing machine, everyone observes at home that there is the tub, washing tub, which rotates, right? It rotates like this with a certain angular velocity, right? Now, if I consider a liquid particle, suppose here, P point, liquid particle, then it is only experiencing W. W is equal to mg. No centrifugal force, nothing, because exactly the particles on the axis won't move in circle. They are just, experiencing gravity. But if you consider a particle over here, particle Q, then I will say it will experience a small pseudo force, and this W will be as it is. And if you go radially outward, bigger is the radius, bigger is the centrifugal force. Bigger is the radius, bigger is the centrifugal force, m omega square r. I'm just writing it here. That in this case, you will get a centrifugal force which is given by m omega square r. That is, if radial distance is more, then centrifugal force is also more. If radial distance is more, centrifugal force is also more. So if you consider a particle r here, then you will have a big pseudo force, and W will be as it is, this much. Now, if you realize that here, this is the net force. Here in this case, the net force will be somewhat like this, if you imagine to complete the parallelogram. And here the net force will be somewhat like this, if you imagine to complete the parallelogram. So, the free surface of liquid is always supposed to be perpendicular to the net force. So, if this is the net force perpendicular to it, this is the net force perpendicular to it, this is the net force perpendicular to it, you will get this. So that's why if you join them free-handedly, you will get the surface like this. Means whenever you consider the washing machine case, the clothes are being washed, the tub is rotating like this, you will always observe a dip or a depreciation at the center. There will be always a dip observed along the axis or at the center, and as soon as the liquid layer you observe, radially outward, you'll observe a height. So whenever the washing tub is moving inside like this in a washing machine, like this or like this, it keeps on changing the direction, you all know. Always you will observe that on the axis of rotation there will be a dip, and in the peripheral layers there will be relatively higher level. That's why the reason is again the same, this property and a centrifugal force. So why we discussed it here? Because this force which is acting radially outward is nothing but pseudo centrifugal force. Pseudo centrifugal force, radially outward. Some other day in detail, or maybe now or maybe some other day in detail, we will talk about pseudo centrifugal force when we will do the comparison of centripetal or centrifugal. But right now I hope you did understand that centrifugal force or radially outward is a pseudo force. You feel it, on a merry-go-round in your childhood, if you stand and the merry-go-round is moving like this, you will feel as if someone is pulling you out. That feeling or that fictitious force is nothing but the pseudo force. So pseudo force, pseudo centrifugal force, it's not a real force, right? It's a pseudo force. You feel it, you observe it, but you don't apply it. No one is there to apply that. All right? Pseudo force, pseudo source, no real source. I hope the story is clear to you. You can take a screenshot of that. All right. So concept of pseudo centrifugal force I have brought. I may discuss it with you. But before that, let us do some problems. If the time permit, we will discuss that today. If the time doesn't permit, that's totally fine. Some other day, we will have a detailed discussion of centripetal and centrifugal forces. Now, a small mass is suspended. Question. A small mass is suspended by a string from the ceiling of a car. As the car accelerates at a rate A, the string makes an angle theta with the vertical. They are asking you the tension in the string. So way one of doing that. Way one. This is the situation. The acceleration of the car is A, is equal to A. Okay. And the bob is somewhere here, mass M. And they are asking you the tension, and it is making an angle theta with the vertical. This angle is theta. All right. So what I'm doing is I'll become an observer and stand here. I'm this observer, observer 1. Okay. So I'm at rest. So according to me, what I'll observe, the forces acting on it is, this is tension, and there is no pseudo force, right? Because I as an observer, I'm at rest. I'm an inertial frame of reference. If I am an inertial frame of reference, there is no pseudo force required here. So the another force which is acting is mg. All right. So this tension I'm going to resolve into two components. This will be one tension component. This angle is phi. So this will be T cos phi, and this one will be T sin phi. All right. So this T sin phi is responsible to provide this acceleration, and this T cos phi is responsible to balance this mg. T sin phi is responsible to accelerate the bob horizontally. Why, sir? Car's engine is not accelerating the bob. No. Car's engine is attached to the car. So the engine will be responsible to provide some acceleration to the car. Or road's friction will be responsible, more appropriately I should say. In friction I'll talk in detail. That road's friction is responsible to provide an acceleration to the car. But on the bob, the only force acting is due to the string, tension, which will have a component in horizontal direction. Gravity will not have any component in the horizontal direction. So one component of tension is responsible to balance the gravity, as there is no acceleration in the vertical direction, and the horizontal component of tension is responsible to give you that A. So in x-axis, I will say T sin phi will be equal to A and MA, and what they are asking, tension in the string. In y-axis, I will say T cos phi will be equal to mg. T cos phi will be equal to mg. They can even ask the tension. They can even ask the phi, angle phi. So if you divide, you will get Tt cancelled. Tan phi will be equal to a by g, or phi will be equal to tan inverse a by g. Tan phi will be equal to a by g, or phi will be equal to tan inverse a by g. That is the one of the answers. Okay, what you have got. But instead of dividing, if you square and add, squaring and adding, you will get t square sine square phi plus t square cos square phi. That will be equal to m square g square plus a square, like that. We all know sine square theta plus cos square theta is 1. So t square is equal to m square g square plus a square. As a result, you will get squaring both taking square root both sides. T is equal to m under root g square plus a square. That is another thing. Here. Okay. So just remember, I don't know examiner what you can expect in the NEET exam here, but I'm damn sure about it that there can be two things, either dividing or squaring and adding. So examiner can ask you anything, and this is how we got the result standing on the ground. Okay, but pseudo force is a tool or technique. As I said, examiner will never tell you that we want you to solve this problem by this technique. Okay, examiner is not going to tell you that. So there is always a way. Of doing it with pseudo. So let me tell you way 2. Previously, we have been an observer standing on the ground. Now let us be an observer who is not standing on the ground, but who is standing exactly inside the cart. Okay, exactly inside the cart. So the acceleration of the car is like this. Car or cart, whatever it is. Okay, it is like this, and the bob is somewhere here, like this. This angle with the vertical is given to you as phi. That is the situation. Now what I'll do, I'll become an observer and stand here. I'll become an observer. This is observer 2. If I'm going and standing here inside the car, then definitely acceleration of the car and acceleration of the observer is same. That is in the forward direction. As a result, there will be a pseudo force. Since right now, you yourself are accelerated, the frame of reference is said to be non-inertial. All right. So if you or the observer is himself accelerated, non-inertial frame of reference, the pseudo must be applied in the backward direction, FP. All right. And definitely there will be W equals to mg here. W equals to mg. And here pseudo will be equal to m into acceleration of the car, A. So now if I'm going to represent this tension and then I'm going to resolve it, if this angle is phi, this angle will be phi, there will be this T cos phi and there will be this T sin phi. T cos phi, T sin phi. Now you can clearly do the balancing. This T sin phi will be equal to pseudo and T cos phi must be equal to weight. T sin phi must be equal to pseudo and T cos phi must be equal to weight. So x-axis and y-axis I'll write separately. So see, x-axis mein I will be balancing T sin phi must be equal to ma. Y-axis mein we will balance T cos phi must be equal to mg. Why we are balancing it? Because if the observer is standing inside the cart, then according to that observer, Bob is not observed to be moving. According to observer 2, Bob is in equilibrium. Bob is hanging in equilibrium. So if the Bob is, see, according to the observer on the ground, the Bob was moving along with the car. But according to the observer standing inside the car, it is just hanging with time. It is in equilibrium with time. So Bob is hanging in equilibrium. In that case, you can just balance the x-axis force as well as the y-axis force. And the moment you will balance that, see, same equation you will get. Exactly the same equation, exactly the same conclusion. So that's what I said, that if the observer is standing outside and the observer is standing inside, one is inertial, one is non-inertial, your observations are going to be different. The way you write the equations are going to be different, but your conclusions, final answers, final conclusions are going to be exactly same. I hope you understood. If you like, you can take a screenshot of that. Understood? Na? Try to feel it. What you will observe as an observer while standing on the ground, what you will observe as an observer standing inside the car. Okay. Let's go ahead with the next one. Go to the next one. This is all the surfaces are smooth as shown in the figure. The acceleration of mass m relative to wedge is the same situation we have dealt so far multiple times, but the condition was it is in free fall or it is no slipping condition, common acceleration condition, some condition was there. Here they are not giving any condition that you want to observe this. Here they are saying that suppose the acceleration is a, what is your observation? So far we have discussed if you want to attain this condition, what should be the acceleration? Now they are saying, let us say the acceleration is a, then tell me the acceleration, then tell me the normal reaction, like that. So I will consider okay, the inclined plane like this, and the block is here, and M mass block, capital M it is, and the wedge is accelerated like this A. Okay, it is given to you. Now what do? You become an observer and stand here. Why you are becoming an observer and standing here, sir? Standing here, sir. The reason is they are asking relative to wedge. If they are asking relative to wedge, then definitely you have to go and stand on the wedge. So if you have gone and stood over the wedge like this, then because of the acceleration of wedge towards the left, the pseudo acting on the block will be towards right. That will be given by mass of the object m, acceleration of the observer a, but in opposite direction as we have seen. This is the pseudo. Okay. So side by side, I'll also resolve it here. If this angle is theta given to you, I'll also resolve the forces. So I will say this angle will be theta. See, alternate interior angle. So it will be MA cos theta, and this will be MA sin theta. MA cos theta and MA sin theta. All right. Now another force is mg, sir. Another force is mg. So W equals to mg. So if I try to resolve it into components, I will say this will be MA cos theta, mg cos theta, and this will be mg sin theta. Okay. So if they are asking you the net acceleration, then if you add them up, then you will say there is a net acceleration because of these two forces. And if they ask the normal reaction, then here will be a normal reaction N or R. All the surfaces are smooth, so there is no friction anywhere. All the surfaces are smooth, no friction anywhere. The only contact force is normal reaction. So I will say this normal reaction will be equal to plus this, like perpendicular to the inclined forces will be balanced, and along the inclined these two forces will be responsible to provide the acceleration. So along the inclined, I'll write two things here. Along the inclined, the net force F net, which is equal to M into A net, that will be equal to MA cos theta plus mg sin theta. MA cos theta plus mg sin theta. As a result, this implies m got cancelled. The net acceleration is A cos theta plus g sin theta. Net acceleration is A cos theta plus g sin theta, and see, that's the result in front of you. A cos theta plus g sin theta, that's what they asked. That's what they asked. And normal to the inclined, if they say normal or perpendicular to the inclined, if they would have asked, your question and answer is done. What other things they can be asking for the NEET exam? Normal to inclined plane, I will say the normal reaction N or R plus MA sin theta, that will be equal to mg cos theta. This implies if they ask the normal reaction N or R, that will be equal to M g cos theta minus a sin theta. G cos theta minus a sin theta, that is the only contact force acting. This is equal to F contact. Once again, I am telling you, contact force may have two components. One is the normal reaction, one is the friction. But here, the moment you call it smooth, the friction is going to be zero. The only component of contact force available is normal reaction. I hope that's cool. That is another model. All right. Easy. Okay. Let me talk about the last model for today. That is also in front of you. A pendulum of mass m hangs from a support. This is the pendulum hanging from a support fixed to a trolley. The direction of the string when the trolley rolls up, and inclination alpha, angle of inclination is alpha. They're asking the direction of the string when the trolley rolls up. They're asking you direction of string theta. Okay, you have to tell me theta. You have to tell me theta, the direction of the string, means tell me what is the value of theta. All right, in terms of a naught and alpha, in terms of g a naught alpha. Tell me the value of theta in terms of gravity, the acceleration over the wedge, as well as alpha, angle of inclination. So the concept involved here, I'd like to give you a reminder of a basic vector concept. When you are writing the angle with y-axis, then it is tan inverse for equilibrium, ax by ay. Ax by ay means with whichever axis you make the angle, that component must be coming in the denominator. And if you are writing phi x, then that will be tan inverse ay by ax. With whichever component, with whichever axis you make the angle, that component must be coming in the denominator. Of what, sir? Velocity vector, acceleration vector, or displacement vector? That will depend on the question. So here you are dealing with the equilibrium, so you are interested in the acceleration components. If you are dealing with equilibrium, naturally you are interested in acceleration components or force components. If you are dealing with the direction of motion, then you are dealing with the velocity components. And if you are dealing with geometrical angles, angle of elevation, angle of depression, then you are interested in the displacement components. Once again, I am telling you, vector rule is very simple. With whichever axis you make the angle, that component of the vector must be coming in the denominator. But sir, which vector components? Displacement vector components, Sx, Sy, velocity vector components, Vx, Vy, or acceleration vector components, Ax, Ay. So if you are dealing with equilibrium like this, then definitely you are interested in acceleration components or force components. If you are dealing with the direction of motion, then you are interested in the velocity components. And if you are dealing with the geometrical angles like angle of elevation, angle of depression in a particular problem, then you are interested in displacement vector components, Sx, Sy. Okay. So here, let's talk about it. So now what will be happening? You will say that A naught is there. So definitely the pseudo force will be acting like this, and that will be equal to m A naught. The pseudo force will be acting opposite to the acceleration of the cart. And okay, so m A naught here. And mg will have two components. One will be like this, one will be like this. This component will be mg sine alpha. This component will be mg sine alpha, and this component will be mg cos alpha. Okay, perpendicular to the incline, mg cos alpha, along the inclined mg sine alpha, and because of the acceleration in the upward inclined up, the pseudo will be acting inclined down. Now suppose the axis they are talking about is this axis y dash and this axis x dash. So do you realize that angle theta, suppose x dash is along the incline and y dash is perpendicular to the incline. So do you realize that angle theta is made with y dash? Angle theta is made with y dash. So here theta made with y dash axis, that will be equal to tan inverse with whichever axis the angle is made, that component must be coming in the denominator. So that will be ay dash, and here it is ax dash. So the final answer is in one step, tan inverse ax dash along the incline, down the incline, that's a plus g sine alpha, And here in the denominator, that's going to be g cos alpha. Along the incline, down the incline, a naught plus g sine alpha, and perpendicular to the incline, that's g cos alpha. I hope you understood how we directly wrote the final result in on the basis of vector property, right? So that's why I say that whatever I taught you a lot, fundamentals, that will only not be limited to 1 or 2 chapters, but that will be very beneficial for the rest of the physics also. All right, so with this here, we do complete the bridge course fundamentals journey till now. And I hope you would have enjoyed the fundamentals of kinematics and laws of motion. Make sure you review them again and again, and you still stay close to the notes provided to you, so that if any, and I'm expecting a good number of problems, so if any problem is repeated in the subsequent exams or the final NEET exam, I'm expecting you to answer it very nicely, accurately. All right, that's all from my side. It was a beautiful journey till now. Hope you will keep emphasizing on the fundamentals the way we have emphasized so far. All right, all the best. Stay smiling. Take care.